Hi viewers, welcome to the sixth lecture of online series of lectures on Introduction to Category Theory. Last lecture we discussed about some important category theoretic concept called products, pullback and equalizer. This lecture we are going to see how we can O-log a product, following which we will discuss about some other concepts called coproduct, pushout and coequalizer, which are dual to the concepts we discussed in the last lecture. Okay, let us get started with how we can O-log a product. O-logging a product. Given two objects, C and D, in an O-log. Remember that O-log is an abstract category where objects are types. So C and D are two types in this abstract category. There is a canonical label. There is a canonical label C cross D for their product C cross D. Okay? Written in terms of the labels, in terms of the labels C and D. Okay, namely C cross D, which is the label of the product C cross D. Okay. This is the label of this product, which should read a pair XY. It has nothing to do with the ordered pair that arises in the context of set. Okay, it's just a pair X comma Y, where X is C and Y is D. So X is the label attached to C and Y is the label attached to D. The projections, so there are two canonical projections, projection onto the first factor and projection onto the second factor, can be labeled yields as X and yields as Y respectively. Okay? So there are two arrows here, okay, associated with the two projections. The label of the first arrow should read yields as X, and the label of the second arrow should read yields as Y. Okay? Okay. Now, we had gone through the universal property of product in the last lecture. By the universal property of products, by the universal property of products. P and Q, by the universal property of the products, we know that if E is another object, E is another object or type of the O-log, another object, and P from E to C and Q from E to D are two given arrows, then this P and Q, these two maps, small p and small q, then P and Q induce a unique arrow, E to C cross C. Remember that we are not calling these functions. These are just arrows, abstract arrows, because we are in the abstract category of O-log. They don't have anything to do with sets, E and C. They are just abstract types or abstract boxes with labels in this category O-log. Okay? So there we'll have a unique arrow from E to C cross D by the universal property of products. Making the following diagram commute. Making the following diagram commute. Okay. So let me draw the diagram that arises in this context. Okay. We'll give a more concrete example for this situation. So let me draw this general diagram here that we have in this context. So we have this product, and we have these two canonical projections. And then for any other object of this O-log and given two arrows P and Q, we must have a unique arrow from E to C cross T. Okay, this is what you say. Okay, so what will be the name? What will be the label of this unique arrow? Let me write for you. So this arrow E to C cross D should be labeled as, so let me put it inside the inverted commas, yields insofar as it P is the label of this arrow from E to C, as P, C is the label of this type, okay, and Q is the label of this other arrow here from E to D, and D is the label of this type here. Okay. Now let me give you an example. Consider the following situation. Every car owner owns at least a car, okay? Owns at least a car, okay? So now, there is no obvious function. For that reason, there is no obvious function from a car owner to a car under the aspect owns, okay? Because a car owner can own more than one car. So the aspect owns in this case will not uphold the functional relationship. All right, but we can modify this aspect and make it work like it. Make it uphold a functional relationship in the following way. So if, one good choice would be the car that the person drives most often. Which we will call his or her primary car. Okay? So now we're saying that, so in this situation, if you modify that aspect a little bit by calling the aspect as owns as primary, like this, a car owner goes to a car under the aspect owns as primary. Now upholds a functional relationship because a car owner owns as primary a distinct car, okay? A unique car. Alright, good. Now let me draw an O-log for you. Let me erase this part. I want to keep that part. So let me get started from the top. Here is called P cross C is the product of the two types P and C. A pair X comma Y, where X is the person and Y is a car. Let me remind you again that these are not sets. These are just abstract types. Okay? And this is just a pair, not the order pair that we have in the context of set. So this is the projection onto the first vector, and we label the arrow as yields as X, and this type is a person. We denote this type by D, and there is another arrow which is the canonical projection onto the second vector, which we label by yields as Y, and this type is just a car. Okay? And now for another type called a car owner. Okay? And two arrows the first one called is, and the second one labeled as owns as primary, which are both valid aspects. Okay, a car owner owns as primary a car. We already discussed how it upholds a functional relationship, and a car owner is a person is also a valid aspect. Okay, so now this E is a car owner, and this small c is a person, and P is the arrow, with the label of which is here. Okay. So what does this arrow tell us? Okay, and how this arrow should be labeled. Here is the prescription. Yields insofar as it PC. The P was this arrow, so which is in this case if, as it is, C was this type, which is in this case a person, as it is a person, and QD, Q is this arrow, which in this case is owns as primary, and owns as primary, okay. And D in this case is this type, a curve, as primary, a curve. Okay. This is precisely the unique arrow guaranteed by the universal property of products. Okay. So this is the old example of a product. Alright. So next we will discuss about finite limit in set. Alright. So which we will do in the next segment. Thank you for attending the first segment. We'll take a short break and get back to the second segment.